This video is about 2's complement using 8 bits. If you haven't already, please watch my 2's complement video for 4 bits to get an understanding of that system. Well, what's 2's complement? It's a system for expressing negative numbers in binary, because computers obviously use negative numbers all the time. So we need to know how to express a negative number in binary. For example, I don't know, minus 23. So how do we express that in binary using, in this case, 8 bits? Well, there are 3 steps. So step number 1 is we write out the positive binary. So we're going to write out the binary for not minus 23, but actually positive 23. Step 2 is flip the bits, which doesn't require any thinking. Step 3 is a binary addition of 1 bit, just a single bit. Okay, so let's begin. So I'm looking to write out the binary for minus 23. Don't know what the binary is, but if I follow these steps, I should have a binary number which is the same as minus 23 in this 2's complement system. So what's the first step? Write out the positive binary. So the positive for this is plus 23. It's a bit weird that we're looking for minus 23 and we start with positive 23, but that's our starting point. 1, 2, 3, 4, 5, 6, 7, 8. So we're using 8-bit binary. Obviously I don't need 128 because that's too big. So is a 64, so is a 32, but I need a 16. To get up from 16 to 23 is 4, is 7. I need 7 more. So 7 in binary is that and that and that, which means I don't need that. So here is my 8-bit binary for positive 23. So we've done step 1. Step 2, flip the bits. Well, this step actually doesn't require any thinking. That 1 is now flipped into a 0. That 1 is flipped into 0. That becomes a 0. That 0 is flipped into a 1. And that's it. So no thinking there. And what's the last step? A binary addition of a single bit. Okay, so we're done with that. We don't need this step anymore. I'm going to put my single bit here, and I'm going to show you that I'm doing an addition. 1 plus nothing, well, that's 1, and then everything just drops down in this particular case. 1, 1, and 1. And that's it. That is minus 23 using the 2's complement system. The first step was write out the positive 23. Second step, flip the bits. Third step, binary addition of 1. And we get the answer. But how do we know that's the answer? You can actually just type into Google 2's complement converter, type in minus 23, press a button, and you should get that same binary as the answer. Let's try another example. Let's try minus 45. So step 1, positive binary. So I need positive 45. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I don't need 128 or a 64. I do need a 32. And 32 going up to 45 is 13. So I need 13 now. So I don't need that. And 13 in binary is 1, 1, 0, 1, 12, and 13. There we go. So this is the binary 0, 0, 1, 0, 1, 1, 0, 1 for positive 45. And I need to flip the bits. Okay, flip. So that 1 becomes a 0, that's a 1, that's a 0, that's a 0, that's a 1, 0, 1, 1. So I flipped all the bits. And then the final step is the binary addition, so I don't need that anymore. So a binary, add the 1 there, draw the line. So everybody, I'm doing an addition. So 1 plus the nothing, well, I drop the 1, and then everything else just drops down. 0, 0, 1, 0, 1, 1. And that should be the binary that represents minus 45 in using the 2's complement system. And so that's how we go about doing that. Okay, so I'll grab a pen. Can I get you to grab a pen and paper and get ready to pause? And I'll put a couple on here. You have a go at them. And here they are. So let's try minus 13 and minus 100. So press pause, grab a pen and paper, and off you go. All right, here are the answers. So minus 13. So write out the binary first. 1, 2, 3, 4, 5, 6, 7, 8. And I want it to equal positive 13. So positive 13, I don't need any of those. 8, 12, 13. Flip the bits. 0, 1, 0, 0, 1, 1, 1, 1. That's the flip. And binary addition of 1. Don't need that anymore. Let's see. So 1 and 0, that's the 1. 1. That drops down, they all drop down. And that should be minus 13. And let's try the other one, minus 100. So 1, 2, 3, 4, 5, 6, 7, 8. And we're obviously going to set up for positive 100. 100, what do I need? Well, I don't need 128. 64 I need. What does that leave over? 64 leaves, that gets to 70, so it leaves 36. So I need a 32. That leaves over 32, 36, 4. So I just need a 4. There we go. And those are all switched off. So that's the binary for positive 100. Now I just flip it. 1, 1, 0, 1, 1, 0, 0, 1. And now I do the add. So binary addition of 1. So 1, 1, 0, carry the 1, 1, 1, 0, carry the 1, 1, 1, 1, 0, 0. And 1. You for that one. Made that better. Okay, so the binary for minus 100 should be 1, let's make that a better 0, 1, 0, 0, 1, 1, 1, 0, 0. And that's it. That's how we express negative numbers using the 2's complement and 8 bits.